Okay, so we'll perform NLP. Okay, basic NLP, natural language processing, right? Okay, so obviously first it's the, let me see if I can, you're seeing Excel, right?
Yes, sir.
Let me
Yes,
see if
sir.
you can see the raw version of this file. Sometimes it may be available, sometimes it's not. Okay, so this is available. So let me directly read this. Now I'm not going to use the Excel. I'm going to directly read this. So I'm here. So I'm going to say import pandas as PD. Link from where to download the data is this. Okay, now we will read the data. So I'm going to say reviews data frame equal to PD dot read CSV, right? And you can simply give this link. Okay, so now reviews.df will have our content. Okay, so let's say this is our content, program one, program one. It will take some time. Okay, so yeah, so now there are different steps that we need to perform, basic steps. Okay, and these are the steps that we perform while dealing with any text. So step one is convert everything into lowercase. Now we know that in string, okay, Python string, there's a lowercase and uppercase, they have a different meaning, right? So if you are to work with text, okay, you do not want uppercase and lowercase case to have a different meaning. Okay, you want them to have same meaning, right? So that's why you convert all of them. Okay, convert entire text to
Lowercase.
lowercase. Okay, okay. Then step two is, okay, there are some it's, we call it as decomposition. Okay, so each um, text here, especially we are dealing with non-English text, right? So there are words which, okay, which are which you cannot read, it's not possible to read as just English text. Okay, so we, like, there are some special characters, especially these French and Portuguese, they have some special characters which we will need to decompose. We need to make it cleaner. Okay, and I will show you every step what happens. So we will perform decomposition on the text. Okay, sorry. Okay, so we'll decompose so that you get a perfect, you don't get non readable text. Okay, so you get readable text basically. Okay, then, and this is required only when you're dealing with non-English text. Okay, for English text probably you will not be doing this. Then same thing is, there are some special characters again which we will convert into our UTF character, which is ASCII value. Okay, convert, we call them as accent or language specific. Okay, language specific words into ASCII value. Okay, something that again we can. So this is decomposition, and this is part of same. Okay, so decomposition is done using this one, conversion into ASCII value. So these two will be doing together. Okay, and then, okay, and while doing so, we will ignore the error, right? Then we see not every text will have an equivalent value in ASCII. So if you are doing it, it will throw error. So we will ignore the error. Okay, that means if there is error, ignore it. Okay, what can we do? We can't do much about that. So we'll ignore it. Okay, then we will do what is called as tokenization. Tokenization is breaking into words. Okay, so we'll break it into words. Okay, and tokenization is important concept for NLP and like Chat GPT and this, they work on this tokenization. So tokenization, each token is like one variable, right? So they try to figure out what variable will come after the first token. Let's say if you display first token, then what will the next token, then third token, so on, right? So that's how they work. So we were going to break this entire sentence into words, and then we will do what is called as stop word removal. Okay, stop words removal. Now these stop words are non-helpful text. Okay, so okay, one of the important analysis that we do on NLP is sentiment analysis. Okay, so sentiment analysis means you are trying to figure out, okay, sentiments that text is or the message is giving us. Okay, so is it giving us positive sentiment or negative sentiments or neutral sentiment? Okay, now in this case, okay, we already have a field called as rating. Rating has those 1 to 5 rating, correct? Now in this case, we don't have to figure out the sentiment, because the um, the the field, the rating field itself will tell us sentiment, right? So if somebody has given you 5, obviously the text associated with that will be positive sentiment, correct? They will not give you 5 and then talk bad about your product. Same way, they will not give you 1 and talk good about your product. So we'll assume that, okay, rating 1 is negative sentiment, rating 5 is positive sentiment. Okay.
Yeah.
So this is
Yes.
one thing. Now, when we talk about machine learning predictive, okay, this is exactly what we try to do. Okay, we will see, we'll take one example. When you're doing machine learning, we'll try to take a text and we'll try to predict whether that's a positive or negative. Okay, here we don't have to predict because it's already given. Analytics, your data set will already be given, right?
Yes, sir.
Okay, so let's continue. Stop words removal. Okay, so oh yes, so we're talking about stop words removals. So if your intention is to figure out, okay, and what we'll do in this analysis is we'll figure out why customers are happy and why customers are not happy. Okay, so we'll figure out adjective words from the text, and that will tell us product customers are happy. But now if you analyze, if you perform such analysis, there are some words which are not helpful, like there, okay, I, when, at. These are words which are used to give meaning to a sentence, but they don't give any additional extra meaning to the sentence, right? So we will remove such words. So in this case, okay, we will the NLTK package that we're going to use has a um, dictionary, okay, set of values, okay, set of values which are stop words. But in reality, you can create your own stop words. Okay, you can build your own stop words, and stop words is basically it's a set values. Okay, set of values, and we will say remove the words which are in this set. So you create a set, you add some values, and we'll say remove the words which are in given set, right? So from the words that you have, you remove those words. So we don't have to deal with 10,000 words. We'll have to deal with only 1,000 words or 2,000 words at max. Okay, that's what that's the intention of removing this, because they anyway don't perform. They anyway don't give us any meaning to our analysis. Then why to carry those many words and make our model more complex? Okay. Okay. So we will remove the stop words. Okay. So, okay. So let's perform these 5 steps first, and then we will see what next we would be doing. Okay. So first of all, we have to read this column, right? So um, if I go back, okay, review comment title. Okay, I'm going to this data set. I'll show you. For us, review comment message. Okay, this is important. Okay, so this column we will work with mostly. Okay, so I'm back here now. Let's say, okay, so yeah, so let's say this is the column. Okay, so that we don't forget. Now we will use NLTK package. NLTK package is used to perform NLP in any language. Okay, it has it is so strong that any language you can analyze using NLTK. So I'm going to say import NLTK. Obviously, I have it already installed in my machine, so that's why it's not giving me error. When you are doing, you have to do pip install. Okay, you have to install this. We will also use Unicode. Okay. Um, for decomposition. Okay, so say Unicode data. Okay, this is it. Now let's read the content. How do you read this column now? So remember, these columns have some uh, uh, missing values as well, right? So for example, if you see here, 1, 2, 3, first 3 data does not have message. Then 4th, 5th has. Then 6, 7, 8, 9 does not have. Okay. So we will remove those values. We don't have to deal with blank values, right? So we will remove those. Those are not helpful for us. So let's see how we can do that. So again, it is more of your pandas application. So I'm going to create, okay, new data set. Okay. So I will say review df equal to. So I'm replacing the existing data set review df equal to review df. Okay. Of, okay, now I'm giving my condition here. What is the condition? Review df of this column is not null, right? Review ds of this column is should come not null, yes. Okay, and I will copy that data to this. So in a way, I'm overwriting the existing data set only. Okay, and let's run it. We'll print it. Okay, so instead of printing it here, okay, so what we'll do, instead of printing the data frame, let's print only this column. Yeah, the data set is also very heavy. There's a lot of data, and it has to read through internet, so it does take some time. Okay, so now you see this. What happened? This is the index that you see. 0, 1, 2, 3 rows did not have any values, isn't it? Okay, so the 0, 1, 2 is not there. Third row, okay, fourth row, fifth again was blank. 5, 6, 7, 8 were blank. So it gave 9. You see, it has read only the rows which have value for this column, review message. Okay, all the null values are gone. Okay, now to this we will apply all these 5 steps. So what I'm going to do, I'm going to create a function here. Okay, I'm going to create a function called def basic NLP, something like that. Okay, let me call this as, so I'm creating a function basic NLP, and okay, I will pass text to it. Okay, and this should return the words, right? We're talking about stop words. Okay, so we'll perform 1 to 5 steps here, and once we perform here, then we have to apply this over this, right? So how do you apply? So you say here, okay, since it's going to return a set of words, right? So we will create a new column. We'll create a new column. I will call this as, okay, review comment words, maybe something like this. Okay, and this is going to be this is your main column, right? Okay, and to this we will apply this this what do you call this function. So if you're applying this function, so I'm saying reviews df, okay, is this column going through this function. So when you say apply, you don't put bracket open and close. Okay, and now we can print the output. So why I did this is that after every step I can show you the output. Okay, comment words, and I'll put something like this so that we know there is a, okay. So for now what I'll do, I will pass text and I will return text. Now you see here the input and output is same, right? We are inputting, we are giving the same output. Okay, so when you run these two, so the output of these two should be exactly the same because we are not performing any of those steps. Okay, so I will perform one step and I'll show you the output. You can see how each of the step is actually changing. So see here, this is the actual value. Okay, and okay, or okay, so printing everything, we can say here dot, okay, head. What will head do? By
First five
default,
values, sir.
first 5 values. If you want more, you can put it here. You can put 6, 10, you can put anything, or 3. Okay, but let's put 5 by default. So we will be able to compare the 5 rows of this one versus the original message versus the words message. Okay. Okay, so this is exactly same. If you see, this is exactly same. Now let's go step by step. Step number 1, convert into lowercase, right? So text equal to text dot lower, isn't it? So this is your step number 1. So now when you run it, let's see, is it converted into lowercase or not? Okay, so see, R was capital, P was capital, M is capital, R, P, M, C all became lowercase, right? You will not find any uppercase here. Step number 1 done. Now step number 2. Step number 2, we are saying remove accent and decompose the text. Okay, so these two together. Okay, so what we'll do here, okay, I'm going to use this Unicode data. So I'll say text equal to Unicode data dot normalize. Okay, so normalize will decompose. So normalize what? I'm going to use NFKD. NFKD is a again it's a data set, okay, in NLTK, which will look at the values, okay, and it is going to remove. So it will have all those special characters and equivalent English characters. So it's going to replace each character. Basically, it is just a big heavy set, okay, where you have old, I mean, this is a dictionary, right? You have old data and the new data. So if the text is like a to the power something else, it should convert into a, okay. That is what this NFKD will do. And I'm saying I'm going to pass this text to it. So if text is passed, this will normalize. Okay. After normalize, okay, we will encode into ASCII and then we will decode into this. So let's see if this normalization works here. Okay. Okay. So it is trying to do, but it doesn't know what to do yet. So I'm going to say encode into ASCII. So this is going to read the text here and then encode into ASCII value. Output value will be ASCII value. And obviously we may not have some values which are there. So those values will say ignore. Okay, so you'll get error, you cannot convert. And then after encoding, we will decode back into UTF-8. UTF-8 is the very common English text. Now let's run and see what happens. This will perform your step 2 and 3. Okay, we are doing steps 2 and 3. Okay, step 2 is because it's a Portuguese, non-English. 3, it's better you do it for any language. Okay, even if it is English, you do it because you never know while moving content around, you might get some unreadable characters. Okay, and unreadable characters will throw error. Okay, so we don't want those errors to be part of our final analysis. So we do that. Now see here. In line number 15 here, you see it is A special A, right? Now see, it has converted into normal A. Okay, this is required because when we perform rest of the steps, okay, it is better that you take English, pure English text, and okay, we analyze using English text only, right? So all the language specific things are now converted and back into ASCII value. Make sense? Yes, no?
Yes, yes.
Next. So, okay. So remember, these are the steps. Okay. So any data set you work with, these are the steps we will do it. Okay. So nothing like, first time you're doing it. So you have to understand. Second time onwards, you have to perform exactly the same thing. Okay. So now you have tokenization. Okay. Breaking into words. Okay. So we will break it into words. So you have NLTK package which will do this for us. So for this purpose, let me use words here. Okay, and this words we will return. So this is going to be NLTK dot word NLTK dot tokenize dot word tokenize. Okay, and to this we will pass our decomposed data or normalized data. Okay, now you want to see the output. So it should be list of words now. Meanwhile, let's prepare for next step.
What is the difference between tokenize and word tokenize?
So tokenize is a library within NLTK which has word tokenize. It will convert into words. So this is your another module in NLTK package.
So like
Tokenize
word
is
means what? Like earlier, it will seem like same, na?
Where?
In above stage, it seems same, na? Output is same. So like in tokenization, like what would be different? Like what kind of words?
Step number 4,
I didn't understand. Yeah.
breaking into words. Break the sentence into words. So these are one full sentence, right?
Mm.
We have broken down into words, you see.
Yes.
Recipe, comma, bem, dot, antes,
Comma.
dot, do, dot, prazo, dot.
Yes, sir, it is easy to read like sentence, na, instead of words. So
No, we are
like why
analyzing
we
the
are
words. We are
converting?
not analyzing sentence. Okay, we want to know for what
Okay,
reason. Okay,
customizable. Huh.
Yeah, why
Got it.
customers are liking your product. Okay. So now when I
Hmm.
want to know why customers are liking my product, okay, now I like your product because of, now I like your product. So like is the word, but I,
Yeah.
because are not
Yeah.
relevant.
Where?
So we will
Huh.
remove
Okay.
those
Got it.
words. So how will you remove those words? First, we will break the
Okay.
sentence into words and then we will break.
Then, yeah.
Yes,
Tokenization.
In the third step, we are converting into first we are converting into ASCII and we are decoding into normal English text, sir.
correct.
But then what is the use of the converting into ASCII and again we are converting into
So see, this is a decoding into ASCII, right? But we have to read the English words, right?
yeah.
So that's why we are converting it back into UTF format.
Yes, sir. Previously it is also there in the UTF-8
No, no,
already,
it
sir.
is not UTF. You see, these are the words, right?
Yeah.
A. You see this? We want to remove such words. You see this E?
Yeah.
We want to
This
remove these such
special
words.
characters.
Yes. So we will convert that into ASCII first. We'll see what is the equivalent ASCII value. And then we'll convert it back into English text.
Hence we need to if we want to convert into UTF-8, we need to convert into ASCII, sir.
If it is non-English text.
Yeah, if it is non-English text, we need to convert into ASCII.
Yes, yes.
Every time we need to
Because
convert into ASCII, sir.
because yeah, because you don't know what is the equivalent value of this in English,
Yeah.
right? Now, if you compare this against 26 alphabets, lowercase, you will not be able to find out. So we are first decomposing and then checking the ASCII value. So all these readable, see, every readable characters will have ASCII value. Okay. So let's go back and check here. Everything that your computer can read, your keyboard can type. Okay. Will have a ASCII value. Okay, so ASCII value is the number, and then you see. So see, null. Okay, every character you see here has a ASCII value. Okay, this is the character, this is the ASCII value. This is the character, this is the ASCII value. Right? So these are the valid characters. So decompose will decompose into A. Then we will convert into ASCII value and then we will convert it back into our text, so that finally you will have only readable text. If you simply decompose, you might have some text which may not be readable, and then later when we perform analysis, it might give error. When you're doing, let's say you're doing translation, so it will not be able to understand what you're doing. It will give you error. So instead, we'll make sure that everything is English text. Meaning is not English, okay, because it's a Portuguese language, but at least to read, you can read it like using those 26 alphabets plus these special characters and digits, right? So this is what your normalization would do. Normalize, then decode, and then encode it back. Decode into ASCII and then decode each ASCII value into your UTF-8 digit numbers. Numbers or text. So decoding and encoding both are required. Right? Shall we move ahead? Abhiram?
Yes, sir.
Okay, so this is your step 4. Okay, yeah. Now we will remove these stop words. Okay, so now to remove stop word, okay, we got these words, right? Now we'll remove the words which which will not have any meaning. So we call them as stop words. Okay, like a and the, I, you, these are the words which we will remove. As I said, right, you can create your own set of words and remove it, or we will use inbuilt. Okay, so I'm going to use inbuilt. Okay, just give me a second, office comments. Yeah, sorry guys. I'm back. Okay. So we're talking about tokenize, that is done. And then what did we say? Sorry, stop words. Okay, yes. Stop words. Step 4, tokenize. Step 5, remove stop words. Okay, we call them stop words. Generally, which are the non-meaning, non. Okay, so we're talking about stop words, right? So for stop words, we have a we call it as an LTK corpus. Okay, and corpus has set up stop words for every language. So for the respective language, you need to tell which language you want stop words to be. So in this case, we want stop word from Portuguese language, right? So let's see. This is how you do. NLTK dot corpus. Okay. Dot stop words. Dot words from Portuguese. Spelling is important. Okay. So this will give you stop words from Portuguese. Okay. Okay. Now we need to build a library. So now how do we use this, right? We'll build stop words equal to, okay, and we'll take each word from this, okay, and we'll also make sure, because see, again, this is a Portuguese stop word, right? There will be some words which are not normalized, correct? Obviously, right? So for each of these words, we have to again go through the same process. So what I'll do, instead of doing this, let me create a function itself. Function to normalize Portuguese text. So I'll say def normalize text. So it will take text and it will return this one. Okay. So now what I can do, I can simply copy this here and pass text here. Right? Okay. Now, same thing we can do it here. So when you have these stop words, okay, we will take each word from this. So we will say for word in this entire directory, okay, and what you get is word, right? So this word we will pass through normalized text. Okay. Make sense? And this entire thing will create a set of values. Set. That means duplicate values will be gone. Did you understand that? What we just did?
Instead of like go through with all the procedure, you just create a function.
Correct. So I'm going through this for loop.
Sir
I'm
wants
getting
to
the output, and this output I'm using to normalize it. Yeah.
Yeah.
3 steps together. Okay. So now we have stop words, which are again normalized.
Normalized.
Okay. And now we will remove these stop words. Okay. Our words we will remove from this stop words. So how do we remove? How do we do that? Again, I'm going to say, okay,
Tokenization.
right. So if we want which words, if let's say word, if W, let's say we use W, if W not in stop words, correct? And okay, if W not in stop words and W dot is alpha. That means W should not be in stop words and it should be an alphabet. Make sense? Okay, then what do you do with this? Okay, we will, okay, so these are the words that we need, right? So these are your words, correct? So from these words, go through each of these words, W, and see if not in stop words, save that. So how do we save? We save as a tuple. But how do we go through each of these words? So we have to say for W in words and then perform if. And what do you get at the end of the day? You get W, right? And this W will convert into tuple. So you're getting a tuple of values, okay, which are not tuple of words, which are not in stop words, and also that is alpha. This is your words here. Okay. Now when you run it, you will get, okay, words which are stop words will be removed. The original values, let's see what we get. Okay, this is first phase. Okay, now we have the actual words that we need for analysis. Okay, 99% of the time, these are the steps that you will perform for any NLP work. Okay. Okay. Now what should we do? Now see here. Recipe is gone. What is recipe? Okay. If you want to know what is recipe, we can go to, and I'll show you at the end how to translate using code. Now I'm going to Google
Google
Translate.
Translate.
Yeah, we will do the translate later. We'll say,
Then why we are not taking English doc
no, I wanted to
for
show you how
exam?
you can do with any other language. Okay. Towards the end, we will translate into English.
Okay.
So we will do translation part also. Okay. So now I'm going to,
One package will be a GTTS or something.
Google, yeah. Okay, Google Translate, we can use Google Translate package only. But let's see this recipe, it removed. So let's see what is the meaning of recipe. Why did it remove recipe? Okay, and this has to be English, right? E. See, I received recipe. So maybe this I received is not a good word too, or it's not important. But BEM, let's say. Okay, BEM, it actually saved. Good. So good is adjective, right? So
Yeah.
good is important for analysis. I received is not important, so you removed the I received. Yes?
Yes.
So this is your first part of analysis. Now what do you want to do? Now in our case, we will plot the project. What we are doing is we are plotting unigram, bigram, trigram. What is unigram, bigram, trigram? These are words. Okay. Unigram
Words.
means one
Names of.
word.
Yeah.
Bigram means two consecutive
One
words.
word.
Trigram is three consecutive words. So why do we need to do bigram and trigram? Why not only unigram? Okay, just like we did, right? Received or good. Okay, not okay. So now if you say good, okay, so it is good. But if the word is actually not good, not is just for good, not good, what happens? It is actually meaning bad, right? So that's why bigram is important. You also need to know what is the word before this good. Is it not or something else? Right? So not good becomes bad, isn't it? So if you had not looked at bigram, if you had gone with just unigram, you'll assume, oh, this person is saying that it is good. But no, when you look at bigram, then you know, oh no, he's saying that it is not good. Come the same way, we go for trigram. That's why we don't go into tetragram, pentagram, not required. Okay, trigram is good enough. So we will take entire data set and we will see what is the most used word in the entire data. So right now what we did was we did row wise, right? For every row we perform. Now we will mix the data and we'll see what is the most occurring word, right? Most occurring word for positive sentiment, for the positive review would mean that customers are probably liking the product because of those features. If I say product is good, product is good. So they like your product because it is good. Okay, received early. Okay, delivered early. Okay, received or delivered damaged. So then you know, okay, it's getting damaged, delivery is damaged. That's why they are not liking your product. Correct? So these are the information we can get from this data set. Okay, so let's do that. So first thing we have got finally the words. Now we will have to convert this into, okay, so before we convert it into, let's say, your rating 5 4, let's convert them into English text. Okay,